Modern data centers process huge amounts of data. Disruptions means business shutdowns and financial losses. By the early 2000s, the traditional three-tier topology for data centers of that time could not longer cope with the growth of traffic, and a new solution was needed. The new is the well-forgotten old. In 1953, Charles Close, an engineer at Bell's Labs, proposes a horizontal switching architecture for telephone networks. Its task is simple: connect each subscriber to any other without blocking and with a minimum number of transitions between nodes. The idea was rethought and transformed into the leaf-spine architecture for modern data centers. At the leaf level, servers are connected, and spine connects all the leaves to each other and routes traffic. The advantages of this architecture are obvious: scalability, fault tolerance, and low latency. In this video, we will show the key steps of launching an IP factory on Eltex mesh switches. Let's consider building an IP factory on Eltex equipment. In our scheme, there are 4 MES 5410 40 switches as leaf and 2 MES 5532 switches as spine. The equipment supports up to 64 routes in the ACMP group, 251 VRFs, and has a dedicated OOB port for management. The first step is to configure the IP address on the leaf and spine ports of the switches for direct connectivity and create a loopback address for each of them. Loopbacks are stable identifiers of devices in the factory network and are important for routing and tunneling. To exchange information about loopback addresses between all factory nodes, one of the IGP protocols must be configured. We use OSPF. In the OSPF settings, it is recommended to set timers SPF delay 0 to minimize route recalculation delays in case of topology changes. ECMP must be activated for load balancing on all spine and leaf switches. This is the stage of setting the underlay level. Let's configure the overlay of the imposed network layer. We are configuring IBGP neighbors with address family L2 VPN to create VXLAN tunnels and exchange information about MAC IP addresses of connected devices. To send the BGP update between leaf, turn on the road reflector on the spine. For a quick response to failures, we turn on the hardware BFD for BGP. VXLAN encapsulations adds 50 bytes to each frame. In order to ensure the transmission of large-size user frames through the IP factory and reduce the share of service information in traffic, it is required to activate jumbo frames on all factory devices. The value of jumbo frames is 10,240 bytes. After that, we configure the VXLAN tunnels on the leaf switches. Now let's move on to the IP factory capabilities currently available. The task of delivering BAM traffic, broadcast, unknown unicast, multicast, is solved in 2 ways. Ingress replication: the outgoing leaf switch replicates BAM packets and sends a copy to all leaves within the VXLAN instance. This is a rather simple method, while creating an increased load on the outgoing leaf and increasing traffic towards the leaf spine. Multicast replication of BAM traffic is performed of the spine switch using multicast mechanisms and the PIM protocol. This method is more efficient in large data centers as it reduces the load on outgoing leaf and does not create additional traffic in a leaf spine direction. In an IP factory with multiple VXLAN tunnels, each ARP request is sent to all leaves within the VXLAN instance, which puts additional strain on the network. ARP suppression is a mechanism that allows leaf switches to independently respond to ARP requests using stored data about MAC plus IP addresses of hosts. This solution reduces the volume of ARP packets transmitted through the factory and reduces the volume of broadcast traffic. When migrating virtual machines between leaf switches, a situation may arise when one MAC address is simultaneously studied for different leaves. This can lead to a loss of traffic. If it is routed along a road, this is already virtual non-existent. MAC mobility fixes this issue when migrating virtual machines. The mechanism works as follows. When a MAC address is detected on the new leaf, it announces a BGP Type 2 route, MAC IP advertisement with the MAC mobility community attribute. Leaf, where is the MAC was previously known, receives the update and sends a BGP withdraw for its own route. All leaves in the factory update their tables and start routing traffic along a new route. When the hosts are connected to the same leaf switch, a single point of failure occurs. In addition, the bandwidth is limited by the capabilities of a single leaf, which does not allow efficient use of the available bandwidth. EVPN Multihoming provides connection of the one host to several leaf switches at once using the lag mechanism over the LASAP protocol with a single ESI identifier. This ensures redundancy and load balancing between all leaf switches. VXLAN provides L2 connectivity between hosts on the same network. To solve the problem of L3 connectivity between hosts, mesh switches support Symmetric IRB technology with L3 VNI. L3 VNI provides the transmission of encapsulated routable traffic between leaf and accordingly between L2 VNI. The advantage of this technology is that there is no need for all L2 VNI to be routed between them on all leaves. In case of migration of virtual machines between servers connected to different leaves using routing, the task of updating the IP record of the default gateway arises. The Anycast Gateway solves the problem. Not only the IP but also the MAC addresses of such a distributed gateway are configured on all participating leaves. As a result, when migrating virtual machines between leaf, updating IRP records is not required, since the MAC address of the gateway remains the same for all switches in the network. The task of the DHCP-relay against is to transfer DHCP packets from the client to the server and back, when the DHCP server and the client are on the different networks. Another function is to add additional option to the DHCP request, for example option 82. In this case, leaf switches act as DHCP relay agent. They intercept DHCP requests from hosts in VXLAN segments and forward them to a centralized DHCP server. So we have reviewed the process of creating a modern IP factory based on mesh switches. Starting with the basic configuration, we have built a fault-tolerant and scalable network architecture with support for key technologies: VXLAN tunneling, EVPN multihoming, symmetrical IRB, and other mechanisms that ensure the efficient operation of a modern data center. A detailed description of the setup can be found in the design guide at the link in the description. The line of data center switches from Eltex is actively developing. New functions are regularly added and performance is improved. We have launched a large-scale testing program, and you can evaluate the data center solution from Eltex in your projects. To do this, contact our sales managers.